In a 208Y/120 volt system, the grounded conductor, also known as the neutral, plays a crucial role. To understand its function, it is important to consider the Y-transformer configuration used in these systems. The grounded conductor is connected to the center point of this Y, providing a neutral reference. Under normal operating conditions, the grounded conductor carries the unbalanced current among the three phases. This means that if the loads on each of the three phases are not perfectly balanced, the neutral conductor will carry the difference in current. This current is typically small and flows from the transformer to the loads and back. However, it is essential to recognize that even this small current means the grounded conductor is actively carrying current. Furthermore, in the event of a ground fault, the grounded conductor provides a path for the fault current to return to the source. This fault current can be substantial and is crucial for the proper operation of overcurrent protection devices, such as circuit breakers or fuses. These devices are designed to interrupt the circuit when a fault occurs, preventing damage and hazards. Because the grounded conductor carries current under both normal and fault conditions, it is consistently considered a current-carrying conductor in a 208Y/120 volt system. Now, let us discuss the derating of multi-wire branch circuits in such systems. The National Electrical Code, or NEC, addresses the ampacity of conductors in multi-wire branch circuits. Specifically, when a multi-wire branch circuit contains more than 3 current-carrying conductors, the NEC requires that the ampacity of the conductors be reduced through an adjustment factor. This adjustment is outlined in NEC Table 310.16. For example, if a raceway or cable contains 3 or 4 current-carrying conductors, the ampacity must be reduced to 80% of its original value. If there are 5 or 6 current-carrying conductors, the ampacity must be reduced to 70%. This derating is necessary because multiple current-carrying conductors in close proximity generate heat. This heat buildup can exceed the conductor's temperature rating, potentially damaging the insulation and creating a fire hazard. Applying this to a 208Y/120 volt system, a multi-wire branch circuit consisting of 3 phases and a grounded conductor presents a specific scenario. Because the grounded conductor is considered a current-carrying conductor, this circuit effectively has 4 current-carrying conductors. As a result, the ampacity of the circuit conductors must be derated to 80%, as dictated by the NEC. To illustrate this with an example, consider a 20 amp circuit using number 12 American Y gauge or AUG copper conductors. Under normal circumstances, these conductors would be rated to carry 20 amps. However, in a multi-wire branch circuit with 3 phases and a neutral, the conductors must be derated to 80% of their ampacity. This means the allowable current is reduced to 16 amps, which is 80% of 20 amps. Therefore, the load on this circuit should not exceed 16 amps to comply with the NEC requirements and ensure safe operation. In summary, in the 208Y/120 volt system, the grounded conductor is always considered a current-carrying conductor, regardless of whether the system is operating under normal conditions or experiencing a fault. This is due to the unbalanced current it carries under normal operation and the fault current it carries during a ground fault. Consequently, multi-wire branch circuits consisting of 3 phases and a grounded conductor must be derated according to the NEC, specifically to 80% of their ampacity, because they are treated as having 4 current-carrying conductors. This derating ensures the safe operation of the electrical system and prevents overheating of the conductors. Understanding this concept is crucial for electrical inspectors, electricians, and anyone involved in the design, installation, or maintenance of electrical systems. Adhering to the NEC requirements is essential for ensuring safety and preventing potential hazards. Now let's delve a little deeper into the practical implications of this derating requirement and consider some additional factors that can influence the design and installation of multi-wire branch circuits in 208Y/120 volt systems. Firstly, it is important to recognize that the NEC provides some exceptions to the derating requirements for multi-wire branch circuits. One such exception applies when the neutral conductor only carries current from nonlinear loads. Nonlinear loads, such as electronic devices, can generate harmonic currents that flow in the neutral conductor. The NEC addresses the situation differently, and it is crucial to understand the specific requirements. In these cases, the neutral conductor may need to be oversized to accommodate the harmonic currents, and the derating requirements for the phase conductors may be different. Secondly, the length of the multi-wire branch circuit can also affect the voltage drop and overall performance of the circuit. Longer circuits will experience greater voltage drop, which can reduce the efficiency of the connected equipment and potentially cause malfunctions. When designing multi-wire branch circuits, it is essential to calculate the voltage drop and ensure that it remains within acceptable limits. This may require using larger conductors or reducing the length of the circuit. Thirdly, the type of raceway or cable used for the multi-wire branch circuit can also impact the ampacity of the conductors. Different types of raceways and cables have different thermal properties, which can affect the heat dissipation of the conductors. The NEC provides ampacity tables for various types of raceways and cables, and it is crucial to select the appropriate type for the specific application. Factors such as ambient temperature, the number of conductors in the raceway, and the proximity to other heat sources should also be considered. Fourthly, proper grounding and bonding are essential for the safe operation of any electrical system, including 208Y/120 volt systems. The grounding system provides a low impedance path for fault currents to return to the source, which helps to ensure the proper operation of overcurrent protection devices. Bonding ensures that all metal parts of the electrical system are electrically connected, which minimizes the risk of electric shock. The NEC has specific requirements for grounding and bonding, and it is crucial to adhere to these requirements to ensure safety. Fifthly, it is important to use properly rated and listed equipment in multi-wire branch circuits. This includes circuit breakers, fuses, receptacles, and other electrical devices. Using equipment that is not properly rated can create a safety hazard. All electrical equipment should be listed by a recognized testing laboratory such as Underwriters Laboratories or all, to ensure that it meets safety standards. Sixthly, regular maintenance and inspection of multi-wire branch circuits are essential for ensuring their continued safe operation. This includes checking for loose connections, damaged insulation, and other signs of wear and tear. Any problems should be corrected promptly to prevent potential hazards. Electrical inspectors play a crucial role in ensuring the safety of electrical systems by enforcing the NEC requirements. They should be knowledgeable about the specific requirements for multi-wire branch circuits and 208Y/120 volt systems and be able to identify potential hazards. In addition to the technical aspects of multi-wire branch circuits, it is also important to consider the human factors involved. Electrical work can be dangerous, and it is essential to follow proper safety procedures to prevent accidents. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses, and working in a safe environment. Only qualified and trained personnel should perform electrical work. To further clarify the concept of unbalanced current in a 208Y/120 volt system, consider a scenario where 3 single-phase loads are connected to the 3 phases of the system. If each load draws the same amount of current, the system is balanced, and the neutral conductor carries little or no current. However, if the loads are different, the system becomes unbalanced, and the neutral conductor carries the difference in current. For example, if one load draws 10 amps, another draws 15 amps, and the third draws 20 amps, the neutral conductor will carry 5 amps. This unbalanced current can create additional heat in the neutral conductor and contribute to the need for derating. It is also important to note that the NEC allows for some flexibility in the application of the derating requirements for multi-wire branch circuits. In some cases, it may be possible to avoid derating by using larger conductors or by separating the conductors into multiple raceways. However, any deviation from the NEC requirement should be carefully evaluated and documented to ensure that the electrical system remains safe. Finally, it is essential to stay up to date on the latest changes to the NEC and other electrical codes. The electrical industry is constantly evolving, and new technologies and best practices are emerging all the time. By staying informed, electrical inspectors, electricians, and other professionals can ensure that they are providing the safest and most reliable electrical services possible. In conclusion, understanding the role of the grounded conductor in a 208Y/120 volt system and the associated derating requirements for multi-wire branch circuits is crucial for ensuring the safety and reliability of electrical systems. By adhering to the NEC requirements and following proper safety procedures, electrical professionals can help to prevent accidents and protect the public from electrical hazards. The grounded conductor in a 208Y/120 volt system serves not only as a reference point but also as a crucial component for carrying unbalanced currents and providing a path for fault currents. Its role as a current-carrying conductor necessitates careful consideration when designing and installing multi-wire branch circuits. The NEC provides specific guidelines for derating conductors in these circuits, acknowledging the increased heat generated by multiple current-carrying conductors in close proximity. Compliance with these guidelines is essential to prevent overheating, insulation damage, and potential fire hazards. Electrical inspectors play a vital role in enforcing these regulations and ensuring that electrical systems are installed and maintained safely. Their knowledge and expertise are critical for protecting the public from electrical dangers.